the polarity of a device with mutual inductance designates the relative instantaneous current directions of such devices' winding leads. A dot marking convention, or alphanumeric marking convention, or both, can be used to denote the same relative instantaneous polarity of two mutually inductive components such as between transformer windings. These markings may be found on transformer cases beside terminals, winding leads, nameplates, schematic and wiring diagrams. Leads of primary and secondary windings are said to be of the same polarity when instantaneous current entering the primary winding lead results in instantaneous current leaving the secondary winding lead as though the two leads were a continuous circuit. In the case of two windings wound around the same core in parallel, for example, the polarity will be the same on the same ends. A sudden current in the first coil will induce a voltage opposing the sudden increase in the first and also in the second coil, because the inductive magnetic field produced by the current in the first coil traverses the two coils in the same manner. The second coil will therefore show an induced current opposite in direction to the inducing current in the first coil. Both leads behave like a continuous circuit, one current entering into the first lead and another current leaving the second lead. Transformer windings, two methods are commonly used to denote which terminals present the same relative polarity. A dot may be used, or an alphanumeric designation. Alphanumeric designations are typically in the form H1 for primaries, and for secondaries, X1. Unlike single-phase transformers, three-phase transformers may incorporate a phase shift due to different winding configurations resulting in a multiple of 30-degree phase shift between H1 and X1 bushing designations. Terminal layout conventions, referring to the circuit diagrams below, the circuit polarity signs plus and dash indicate the relative polarities of the induced voltages in both coils. That is how an instantaneous magnetic field traversing the primary and secondary coils induces a voltage in both coils. The instantaneous polarities of the voltages across each inductor with respect to the dotted terminals are the same. The circuit arrows indicate example applied and resultant relative current directions. The plus and dash polarities in the diagram are not the voltages driving the currents. The instantaneous directions of the current entering the primary inductor at its dotted end and the current leaving of the secondary inductor at its dotted end are the same. Subtractive polarity transformer designs are shown in the upper circuit diagrams. Additive polarity transformer designs are shown in the lower circuit diagrams. Autotransformers, if two mutually coupled inductors are in series, the dot convention can be used in the same manner as in the case of autotransformers. Relative polarity in autotransformer drawings is usually quite obvious by physical placement of the windings in circuit drawings. See also, electrical polarity, instrument transformer. References. Bibliography, Alexander, Charles. Fundamentals of Electric Circuits. McGraw-Hill. ISBN 0073529559. ANSIEC 57.13, American National Standard Requirements for Instrument Transformers, Brenner, Egon. Javed, Mansour. A Section 18.1 Symbols and Polarity of Mutual Inductance in Chapter 18, Circuits with Magnetic Circuits. Analysis of Electric Circuits. McGraw-Hill pages 589–590. Boyle-Stodd, Robert L. Section 21.8 Series Connection of Mutually Coupled Coils. Introductory Circuit Analysis. Prentice Hall. Pages 954. ISBN 0-13-097417-X. Knowlton, A. E. Standard Handbook for Electrical Engineers. McGraw-Hill. Pages 552, A Section 6-15 and pages 606, A Section 6-162. Cathari, D.P. McGrath, I.J. A Section 3.7 Transformer Testing in Chapter 3, Transformers. Tater McGraw-Hill. Pages 73. ISBN 978-0-07-069967-0. Parker, M.R. Euler, S. Webb, WEA Section 2.5.5 Transformers and A Section 10.1.3 The Ideal Transformer. In Whittaker, Jerry C. The Electronics Handbook. Taylor and Francis pages 172, 1017. ISBN 0-8493-1889-0.